All right. Today, you guys are going to be working on problems that we had discussed on Wednesday. So you guys could pull out your practice packet here. We're going to look at a few problems just together. On Wednesday, we did problems 1 and I believe 9. 9 being Hess's law is what we ended off class with. Today, we're going to do problems 2, 5, and 10. What I would like us to do by the time I get back on Friday, if all goes well, is I'm hoping that we can get through problems 1 through 11. If we can get through 1 through 11, we're going to be in a really good place for this unit. So taking a look at problem 2. Problem 2 says how much energy is absorbed when 0.034 grams of water are melted at 0 degrees Celsius. And then it gives us a change of H, I think it's a fusion, heat of fusion here, is equal to 6.1 kilojoules per mole. Now, if you remember from Wednesday, we said we are not going to use the equation we used last unit, which was change of H is equal to mass times specific heat times change of temperature. We're not using that because if you take a look at our temperature, it's saying it's being melted at 0 degrees Celsius. And as we discussed yesterday, if we're melting, the temperature is not changing. Temperature never changes during a phase change. Well, if it's not changing, it is not going to affect our problem. So we are never going to have a temperature, which means we're not going to use that equation. We're also not going to use the train track equation where we go grams to moles to kilojoules, because in order to do a mole to kilojoule conversion, we need a balanced equation, and there is no balanced equation in this problem. So we can only use the equation I've got written right on the side, which is Q is equal to N times the change of H. Q being the energy, N being moles, and change of H being the heat of fusion or the heat of vaporization. So we write out our equation here. Q equals N times change of H, Q being energy, N being moles, and change of H being heat of fusion. Oh, I don't know why I'm writing that. Now, in this problem, it says how much energy. We want to find out how much energy. So question mark on the Q. We don't have a mole value, but it does give us a gram value here, 0.034 grams. So we're going to take that value, 0.034 grams, and we're going to convert that into moles. So grams on the bottom, always going to be 1 mole, and we are going to divide by 18.02. So when you type that into a calculator, you get a very, very small number. You get 0.0019 moles. That's what I got. So we're going to plug that into our N value, 0.0019 moles, and our change of H, it lists up top, is 6.1 kilojoules per mole. So to find this problem, we are going to multiply, as it lists, N times H. So 0.0019 times 6.1. And we get 0.012 kilojoules. It's a pretty small number there. Take a look at 5. Problem 5 is using the same equation. Q is equal to Q is equal to N times change of H, Still the same equation here, but we're starting from a different place and we're ending in a different place here. So we've got Q, N, and H. Five says, what is the mass of ice that can be melted at 0 degrees Celsius if 75 kilojoules are absorbed? H is going to be equal to negative 6.1 kilojoules per mole. It says right off the bat, melted at, clicked the wrong, I was trying to highlight it there. It says it's going to be melted at 0 degrees Celsius. If it's melting, phase change is occurring, we do not need to include it. If it's melting, we're not going to include the temperature. So we take a look at what we've got. It gives us 75 kilojoules. Kilojoules is a measurement of energy, so that's our Q value. And it also gives us negative 6.1 kilojoules per mole. Now, to be quite honest, I do not care if you guys put a negative value here or if you turn this to be positive. I think I might encourage you to do positive. This is where it's going to come into play where we're talking about absorbing something. I think we're going to get into all the acidics of the positives and the negatives. I don't think that's going to be really where we want to dive in. So I would prefer if you guys just labeled something as being absorbed rather than positive or negative. So we're going to change that from negative 6.1 to positive 6.1. So this is going to give us N, which is our moles. So if we plug this into our equation, 75 is equal to N times 6.1. So we're going to divide by 6.1. Giving us 12 point, well, for 2 sig figs, that's right at 12 moles, right? If you didn't round there, that would be 12.3. If you're not going to round right away, that's okay. 12.295, you can keep that. Just know our numbers will be a little bit different. But we've got to convert this now to find the mass, to find grams. So we're going to put moles on the bottom, grams up top. We're talking about ice, which is water. Water, if you look on the periodic table, has a molar mass of 18.02 per 1 mole. So we take 12 times 18.02, and that gives us 216, but we need to do 2 sig figs, so 220, not kilojoules, 220 grams of water there. Our last problem that I want to talk through is number 10. Problem 10 is a Hess's law problem. It's what we ended off with yesterday. So what you're going to see here at the top is an overall equation or overall reaction. Your overall reaction is our end goal. That is what we're trying to get to. So we're trying to figure out get our reactants and our products to match. We know anything on the left side of the arrow is our reactants, and anything on the right side is our products. So the first thing I want us to find here is I want us to find 2CO. If we take a look, 2CO is in the first equation, but right off the bat, we'll notice that it is on the opposite side of our arrow. On this arrow, on the overall equation, it's on the left, but in our given equation, it's on the right, which tells me that we are going to have to flip this entire equation. So I'm going to put 1A at the bottom for our adjustment, and we're going to flip this equation. So you get 2CO makes 2C plus O2. We'll include the states of matter, so G for gas, S for carbon, G for oxygen there. Now, since we flipped, I guess we can cross this off now that we flipped it. Since we flipped it, we've got to change our H value. We've got to flip our H value from negative 222, giving it a positive 222 kilojoules per mole. All right, so we've lined up our two COs. If you take a look at O2, oh, wrong button there. There we go. Awesome, thank you. Take a look at our button. We've got O2 here. O2 itself appears twice, okay? We're going to worry about O2 later then. It appears twice. It'll be something that we're going to worry about later. Then we got to take a look at CO2. We see we've got CO2 on our right side, CO2 on our right side, but right off the bat, there's something I noticed. I noticed that it says 2 CO2 in our overall reaction, but it only says CO2 on our given, which means that our given is half the amount it should be. Well, in order to make it match my overall reaction, we've got to multiply in this box in order to get up to 2 CO. So we're going to put a 2 here, a 2 on O2, and a 2 on carbon. We are doubling the amount in that balanced equation. Well, if I've doubled my amount of total particles, doubled my total amount of elements and compounds, that itself is going to double my total energy. So let's multiply 394 times 2, giving me negative 788 kilojoules per mole. All right, now we've lined up everything to get it kind of work out. We'll take a look at the O2 here. Let's first line up what we can cancel out here. We notice that there's no carbons listed anywhere in this balanced overall reaction. If we take a look, we've got 2 C's, 2 C's. Those carbons can cancel out. Now, if we are to add up our reactants here, we will get 2 CO, which is a gas, plus 2 O2, gas, makes, we add these up here, 2 CO2, gas, plus O2, gas here. We'll notice that there's one thing that's still repeating. We've got O2 and 2 O2s. So let's simplify here. If we subtract the O2s, we're going to end up with 2 CO, which is a gas, plus now 1 O2, gas, making 2 CO2 gas, which if we take a look at our starting equation, that is what we wanted to end up with. Our final thing we have to do for this problem is our change in enthalpy. So we've got negative 788 from here plus 222. When we add those up, you get negative 566 kilojoules per mole. Like I said, if you guys can get through 1 through 11, I think we'll be in a really, really good place with me coming back on Friday.